people typically say about Galvanize? They just, when they say like, "Thanks for coming to Galvanize," like.
Yeah. This is what I do. This is what we just talked about. And if anybody's interested, here's the details on this. Tuesday, Thursday, Saturday, blah blah, here and there, class. October 23rd, and we're going to start a deal for Boulder members, whatever it is.
Perfect.
And then we'll go from there. Really.
Maybe a good place to put my business card. So I can say, like, if you want more information, feel free to grab my card. And
yeah, that'd be great.
Yeah, we can. I think I've seen people put stuff on that table before. Is that Allie?
That's Allie, yes.
Okay.
And so we got, this is working.
Okay.
So this is yours. Where's Dean? We'll give this to Dean.
Okay.
And then,
Like he's digging in the beer.
yeah, we're all running. I checked YouTube.
Sweet. All right. It's working. All right, good evening, everybody, and welcome to Analyze Boulder number 65. If you don't know who I am, hi, I'm Patty. I'm the token extrovert of this group. And normally Tony is here, but she is out today, and I'm trying to take her place.
Hi, Tony.
She's the videotape me. Anyway. Well, with the live stream, you know what I mean.
Yes, you can hear.
There you go. See, Tony is here. I tried to do my hair in curls, but it all fell out. Sorry, guys. No, anyway, welcome. I hope everybody has their tasty beverage of choice. And thank you all for being here. Without you, we never would have got to 65 meetups. Thank you to all of our organizers, Tony, of course, Greg, and Eric, Jen, who I don't think is here tonight, me, and me, who's going to run around with the microphone. So if you have a question, he is the one who you're going to talk to. And now for just a minute, I'm going to turn this over to Allie from Galvanize.
Hey everyone, thanks so much for coming tonight. I just wanted to talk a little bit about Galvanize. We are an event space. We have membership options, and we also are a school. Currently, we do not have a full-time data science immersive at our Boulder campus, but we do have an intro to data science course coming up on October 23rd. It's a part-time nights and weekends course. It meets Tuesdays and Thursdays at night, and then there are 2 Saturday days that are held at our Platt campus. We worked out a sweet little deal for Analyze Boulder and are offering 50% off. It's typically a $2,500 course, so if you use the word analyze with a Z, all capital letters, you get 50% off of that course. It really is to dip your toes in, see if data science is a track you want to go down. It's also a really great refresher. So you get 4 weeks of Python, you get machine learning, and all the ins and outs of data science. So it's an 8-week course, 50% off, use promo code ANALYZE. I have some business cards over on that corner of the table, so if you are interested, have specific questions about the curriculum or the instructor, feel free to reach out. Have fun.
Thank you. And thank you, Galvanize, for hosting us, like always. All right, so we have some great presentations coming up. We are going to start with Andrew on how to buy an election. Kirsten and Speckles with the Toronto leader is going to come up next. And if you haven't followed Speckles the Hedgehog on Instagram yet, you totally should. It is so worth it. And then we will finish up with Kirk and the self-organizing facts.
Yeah,
Is it not in there?
It might be.
Oh, okay.
It's out of whack.
Oh, no.
All right, we'll come back to it.
So just come back at the end, I guess?
No, we're going to see.
Okay. So, sorry guys, we're throwing off. The deck is out of order. But in the meantime, feel free to get connected with us, whether you want to come and join us on Slack. You just have to email Tony for that invitation at uxtony@gmail.com. You can come and join us on LinkedIn, and you can follow us on Twitter at Analyze Boulder. So make sure you take a picture of this slide if you haven't already followed us in all of these places and joined our groups. It'll be great to see you there. All right, so now we will get into our announcements. So events are going to go first, and I have a note from Tony to announce another awesome discount for you guys. There is an event coming up, a startup weekend for Boulder Space. So you can join them to learn how to launch a space startup in a weekend. This is going to be October 12th through 14th at CU Boulder. And let's see. So the note that I have is that these problems and opportunities in the aerospace industry revolve around data analysis and software, and the people at Analyze Boulder, I think, would be very interested in it. So I have the link for it. I can post it on the Slack. I can put it up, and usually there's a whiteboard to write things up on, but it is communities.techstars.com/USA/Boulder/startup weekend 12391. And if you use the code MEETUP, you'll get a 25% discount. And I promise I will post this up for you guys so we can actually see this. And I will put it, so we can actually get more information on it. And if you are curious and you want to read all about it, I actually printed off their little flyer. I'll put that over on the table as well. So afterwards, when we get back to social time, you can see it over there too. So then, anybody else have event announcements? Conferences, workshops, collaborations, projects, anything you want to share?
So another one that we found out about it, some of you have heard, many of you have heard, go to Colorado. So they have something that's coming out November 8th. If you look it up, I think that's their kickoff. They're going to have 3 different tracks, one of which is going to be a data analytics track. That's due this year or this fall. So if you're having interest in that, check out Go Colorado. It starts November 8th. We'll mention it the next one. On November 6th, so that'd be the 5th last one.
Okay, more announcements. Anybody have an event? See no events or projects, let's move on to jobs. So who wants a job? Who's got a job on offer? It just takes a minute? Yeah.
Hi, I'm Lee. I'm from Logic. We're a proteomics company here in Boulder. We've got a couple different spots open on our bioinformatics team. We're largely an R group, a little bit of Python here and there. So if you're interested, find me. Thanks.
Hey, my name is Devin. I've been a long-time lurker at Analyze Boulder, and back now to announce that we are hiring. I work at a company called Leo. We have an office upstairs. Leo does endurance sports motion analytics, so that's why we're in Boulder. If you speak languages like Python and/or Japanese and/or running or biking or any endurance sports, and like to combine those 3, then come talk to us. I have to step out. I won't be able to stick around after the event, but my colleague Neo is here. She's waiting me, so I'll say hi. And hope to talk to you soon.
Hello, I'm Alan Lindsay with PetroDB. We create geospatial intelligence platforms, and we're looking for some developers. So we need some people with React, with a REST interface background, and preferably with open layers. You all have experience with that. We're also looking for data technologists, people especially familiar with PostgreSQL. If you fall into those categories, well, give me a shout.
More jobs.
Hi, my name is Jada, and I work for Curly. We're a SaaS startup here in Boulder, not so much a startup anymore. We are hiring a data couple data scientists for either Stanford, and we're hiring every from years to office admins, salespeople, for office. So you can on top.
All right, any more jobs? Say, I've got one, but it's not really data. If you guys have talked to me at all, you know that I work in graduate admissions at CU Boulder. In fact, I've run graduate admissions at CU Boulder, and I am hiring a graduate admissions coordinator. So part of what I did was build out an entire admissions platform system, and what you would be doing would be helping me with that. For reasons. Though this is a full-time position, and it will continue on well past maternity leave, I promise. And also, this person will get to help out with the graduate school website and do some other fun little techie things. So it's one of those you can make it what you have. I know it's not necessarily just data, but hey, if you're interested, you can come and chat with me afterwards. All right. No more jobs? Anybody looking? Want to throw yourself out there? All right. Sam on this side.
Hi, I'm Andrew Brodsky. I'm a social policy research consultant. I've been working in the social policy realm for about 15 years, and I'm expanding my client base to small businesses. So I'm trying to find people who are small businesses who maybe don't have the skills or capacity to do analytics on their own business. I call it quantitative therapy for your business. And I'd like to find some folks who do some free work to kind of build out my portfolio and see what people need and what works and what doesn't work. So talk to me if you want a little free work for your small business.
Anybody else looking for a job? Okay.
I'm a data scientist. I have a little over a year of experience working in the consulting world. It's a pretty broad experience of R, SQL, the standard vanilla stuff. I also have a PhD in operations research. So I was job searching here a couple of years ago, eventually found that job. I laid off a month ago. So looking for my next cool thing now. So
What's your name?
so hard to
All right, so now going backwards, we are going to get started. So Andrew is up first. If you want to come on up, we'll get you going. Warm welcome for Andrew.
Okay.
That's the question.
Oh.
Yeah.
Ooh, that would be fun. Yeah. Sorry about that. Yeah, there we go. Okay.
Okay, I'm still Andrew Brodsky. I'm a social policy research consultant. I do a lot in analytics and finance. So I'm going to talk about how to buy an election. So I did a project, a machine learning approach to predicting federal election results. So why is this important? So two reasons. One is that it's an obvious social benefit. So we want to protect our democracy against possible negative effects of too much money in the political system and campaign funding. So we want to understand the mechanism and know if it's effective, where it's effective, what the negative effects are. And if you are working for one of the good guys, you can help your candidate get elected if you understand where your resources will go. I'm not going to tell you who the good guys are. That is a project for you at home. But if you're sure you're working for them, then you can use this methodology too. So work on predicting federal elections. You're probably familiar with these folks down here. And most of the existing models use polling, which is probably the strongest predictor of results, especially as you get closer to an election. But it tells us about the current state of the race, but it doesn't tell us much about the mechanics, why things are happening, why someone is winning, and it typically doesn't give us a more complex understanding of more complex relationships in the data. And it allows us to look at the current cycle, but doesn't necessarily let us predict what's going to happen in the future. So this is the data that I looked at. So here we're going to look at basically what the outcome variable was. In that. It's the spinning wheel of that.
Uh-oh.
But I'll tell you what the map says. So what you're seeing is a map of the U.S. in the snowstorm that shows all the congressional districts and whether they were red or blue in a particular year. And so I looked at what the U.S. House of Representatives composition was over time and how it changed from 2010 to 2016. And that was what I was trying to capture.
Uh-oh. Pause this time, please. Okay. All right.
So I'll go ahead a little bit while you're doing that. So that was the outcome, and then so see the second. I had a bunch of large public data sources. So the most interesting, I think, was the Federal Election Commission. So they have data on every. Yeah, cool. So yes, that's later. Okay, so this is the change over time. So the FEC has 40 million records of campaign contributions, which is a really rich data source. I only got like a teeny bit into it. There's information about dark money spend. The ACS, which is part of the census, has tens of thousands of data points on every census district. And then I had the information on each of the candidates. So what did this model look like? I'm predicting the vote totals. So many models look at who will win. I wanted a more continuous outcome variable, so I looked at how many votes the Democratic or Republican candidate might get. It doesn't use polling data, and I compared a few different models, a linear regression, a random forest, and a gradient boosted regressor for about 3,000 candidates. So how did the model do? The best one was the gradient boosted regressor, which had an R squared of 0.82, which is meaning it's getting over 80%. It's capturing more than 80% of the variance in the data. And this was pretty good. The best existing model I could find, which was by researchers at Google and Microsoft, was about 0.845. And so it was telling us something important. Now this was really interesting. So I looked at all the different features that might predict election results. And these were the most important ones, so the ones that were most predictive. And the ones in green are financial related. So contributions by individuals and committees, and then dark money spent on behalf of a candidate were the biggest predictors. So just looking at this, money matters, you can see. So I took this and tried to look at what might happen in a particular district. So I took a bellwether district, which is a swing district that is likely to predict what will happen in the rest of the country, and saw what would happen, used the model to predict what might happen if you change the infusion of money. So I modeled it by taking the average contributions across the whole country, 768,000. So if each candidate spent that much money, the Republican would be expected to win by almost exactly what they actually won by in 2016. But if you, say, increase by quite a bit, if the Democratic challenger got some funding somehow and threw $7 million into the race, then they might actually eke out a win. And just a note that I would make is that these two are modeled independently in this model, so it doesn't capture exactly what that the Republican might also, as a result, try to put money in the race. But you can see that money definitely matters. And I think that's it. So, questions? Yeah. Yep.
So was there any events by redistricting?
By redistricting, I didn't look at that actually. I treated them each independently.
So someone else had a question?
Did you split it out? It would be interesting to see how the open seats worked. In terms of, do you see any difference between the open seats and the incumbents?
So I did include incumbency in there. It may be in this table.
But they're not, usually it's the open seats where it's like almost apples.
So
Incumbents usually like 500
So one of the nice things about this model was that I separately had incumbency and campaign contributions in there, so it could piece them out. I was just looking back to see if it was one of the top 10 features, which it wasn't, but incumbency was in the model, so it wouldn't it would like implicitly capture an open race because there would be 2 non-incumbents in it.
If you think about it, it'd be really interesting to see how this works before 2000. That was Citizens United. That whole
Yeah. Yeah. So I ended up with about 30. I started with several hundred, and here we are.
I've always heard that like with individual contributions, especially kind of towards like within the law of the election itself, people just kind of stack. So like they're kind of betting on the popular that they think they actually will win. So like have you kind of trying to bring it out by individual contributions 6 months out, 9 months out, or 3 months out, that kind of thing? Because those things are kind of awkward.
Yeah. I did, and I think that would be useful because the further, I think this model works better the further out that you are, because it's maybe like a leading indicator, and then as you get closer, the polling for one will be much more predictive, and that would be interesting to look at.
So it's driving more individual contributions, so there's a lot of
yeah.
All right, any other questions? Well, thank you very much. All right, and next up, we're going to have Kirsten. She's going to tell us all about speckles, who, like I said, you should all follow. If you're, into hedgehog pictures.
Who isn't? Awesome. So, hello everyone, I'm Kirsten Klinger-Smith, and I'm a product designer at Cognizant Quick Left. For those of you who have been here before, you've probably heard Tony say that she's always looking for people to present on their side projects and pet projects. So I'm here to talk about my literal pet project, the Traptometer. So a while back, Viget, which is a digital agency just down the street here in Boulder, hosted a wine and wires event where they provided attendees with wine and a little particle photon, which is this Wi-Fi enabled microcontroller that you can put on a breadboard, similar to an Arduino. So I was trying to figure out what to build during this event, and I was throwing out all these ideas one night, and then suddenly the one idea popped into my head. So real quick, a little bit of background. I do have a hedgehog. This is her. Her name is Speckle. She's pretty cute. And I've had her for about 3.5 years now. So I like to think that I know her pretty well. And I'd say her 3 main hobbies are burrowing and hiding from me, eating cat food, and running on her wheel. And I always wanted to know how much she ran because I assumed that she ran a lot. But I didn't know how much because hedgehogs are nocturnal, so they're mostly active at night. So the grand idea that popped into my head was to create a Fitbit for hedgehogs. But the reality is that the photons are a little too large to put on a hedgehog. So for reference, she is about the size of my hand, so not very big. And you can see her here with the photon itself. So instead what we did was we took the photon and hooked up a magnetic sensor to it. And then we hot glued a magnet onto the back of her wheel so that as the magnet passes the sensor, it picks that up and logs as 1 revolution. So here you can see me kind of testing that. There's a tiny little red light up towards the top there. So every time it passes, it logs that. So Particle sends that data to a project that we set up in Keene, and it aggregates the number of revolutions in the past 24 hours and all time. I then take that data and pull it into a Google Sheet where I calculate out how many miles she ran that night, how many miles per hour, and her fastest speed for that particular set. And there were a few surprises that I found once I actually started collecting this data. So first, she doesn't run nearly as much as I thought she did. Online, I was seeing stats from other hedgehog owners ranging from 2 miles a night to 12 miles a night. Clearly, these don't match up. And 12 miles is like almost a half marathon, which is just insane for a tiny little hedgehog. And I assumed that she was one of those half marathoners. But the most I've ever recorded her running was this 855 revolutions here, which is about 0.6 miles. So not very much. The second interesting thing was her pace and the timing of her runs. So she doesn't seem to run regularly at any particular time of night. The earliest she started running has been around 8:40, and the latest she started running has been around 5:20 a.m. And there's also a lot of nights where she'll get on her wheel, then get off for a while, and then get back on randomly. So you can see that here where she got on around 9:15 p.m., got off for almost 8 hours, and then got back on around 4:50 a.m. So in terms of pace, the fastest she's ever run has been 1.4 miles per hour, which seems pretty fast to me, and it can be a little hard to picture. But to scale it down, that's 2 feet per second. And again, she's roughly the size of my hand, and 2 feet per second would be roughly from my fingertips to my shoulder in 1 second, which I think is pretty awesome. So I'm really happy with this project, but there's a few things I would love to add in. So right now I'm doing all those calculations myself and plugging them into the spreadsheet. So automating those in some way would be really nice. I also would love to add in a sound sensor. So hedgehogs are spooked very easily by sound. So seeing if sound effects when Speckle runs or stops running would be really interesting. And I'd also like to add in a light sensor. Since hedgehogs are nocturnal and run at night, it'd be interesting to see how much ambient light affects how much she runs through the course of a night. So yeah, that is the trottometer. It was a lot of fun working on this. It was super interesting to see the data for the first time, and also it's fascinating being proven so wrong on my assumptions. As a product designer, I get that all the time because we're constantly validating all of our solutions with users, but I just thought I knew this particular user pretty well. Yeah, if there's any takeaway here, it's just always be testing, and especially testing your assumptions, even if you think you know the user really well. So I'd like to give a super quick shout out to Bigot for hosting the event and providing a particle to photon to everyone. And a few of their team members, Albert, who's here in the front, Eli, and Justin for helping me out. And if you want to contact me, there's my email and my website. More importantly, if you want to follow Speckle, just search for on Instagram. I sometimes remember to post an update on there. So yeah, thanks so much for listening. Are there any questions?
Who has questions about hedgehogs?
So Speckle is 3 years old?
She will be 4 in December, so she's getting up there in age.
Yeah, so how long are your hedgehogs? In the layer state?
Yeah, typically like 4 to 7 years, so she's definitely up there, but still really full of spunk.
Maybe the marathon.
Yeah, I didn't get this up and running until she was 3 or 3.5, or actually she was like 2.5, so it could have very well been that she was past her prime in terms of running.
Even I don't know much about hedgehogs, so I was gonna ask, like, where did you keep that matter is separate, and then I saw the very much in the so is she like, is the hedgehog always in this while when you're doing like when you run these tests, are they all day long, all night long, or 24/7?
Yep, it's 24/7, but she only runs at night. So the rest of the time is just kind of downtime. So that would be the other cool thing to add in, is if I could just like shut it off during those times and not even bother with that. That would be really good. Although it would be really interesting if she did run during the day. I don't know why she ever would, but.
What else? Right, I'm gonna run. Sorry.
All the way up there. So I was curious if you actually think getting hedgehogs really run like all miles, like how did those other get their data?
Yeah, so a lot of people use like they'll use stuff that measures how much distance you travel on a bike and stuff like that. So I have no idea how much they have to do to adjust for the size of a wheel versus a bike wheel, or if they do. So it could be false or incorrect data. But I was seeing that from quite a few places. So my assumption is that it is correct data. And they certainly run a lot in the wild because they are foragers. So at night, they're just out all night, just running around, looking for bugs and things to eat. So yeah, it wouldn't surprise me if that data was correct, but I would be very interested in seeing how they adjusted things to account for this very small wheel.
Is there any way to get some meters for your dog? Because I think she could deal with it. Like the things you took.
Yeah, that would be super cool. You'd have to have some sort of like motion sensor instead of like this is like you could kind of do it if you had like a magnet on one and then a magnetic sensor on the other leg. But with this particular setup, I think that would be the only way, and that would be pretty clunky and sort of like a hedgehog, like having some little wearable is pretty hard for them. Yeah, I think that there's stuff out there like little Fitbits for dogs.
Well, thank you so much. All right, and next up, we are going to have Kirk.
Okay. There you go. Take it away.
There you go.
Thank you very much. I want to thank the organizers and Galvanize. This is about my 25th one of these, and I love them all the time. And just to set the tone, there's no way I'm going to follow up that because that was awesome. This is going to be way more geeky, so sorry about that. Take a nap now. So I want to talk about self-organizing maps. So this is stuff that I've done for a long time. I did a lot of this stuff a long time ago. None of this is the specific things that I did, but it's kind of in the same realm. And keep in mind what we see here, this is actually a topology or a topic map that's been trained on with self-organizing maps on the contents of Wikipedia. And so you can see that there are certain content subject areas that group together. So what the heck is a self-organizing map? So they're typically within the world of neural networks. Seems odd to me that they're in neural networks, but there's a reason for that, I guess. They're very similar to clustering. The advantage over just standard clustering, and one of the reasons that I started using them, is that the adjacent nodes in the map carry information from the other adjacent nodes. And so one node next to the other is kind of similar to that one, and then the next one over is similar to that one, but less similar than the third one over. And so you get this more spread out information about the adjacency and the actual topology in the space that you're trying to model. And like I said, the trained self-organizing map actually adapts to the overall topology of the data space that you're operating in. So whatever high dimensional space you're working in, the self-organizing map tries to find that and give you a projection into a lower dimensional space. So the basic way that it works is that you essentially define a topology. The easiest topology is the simple square grid topology. And the adjacency is obvious, so the general relationship in the nodes to each other are built as you see them here. Now the nodes have this kind of double life that they do have a topology relationship to each other, so your standard rows by columns kind of grid, but they also have a representation that defines how they behave in the data space. So if you're operating in a 5,000 dimensional space, they have a representation that says they look like this in that space, but they also have a representation that says they look like this in their topological space. And so what that does is it gives you this capability of dimensionality reduction to be able to take these super high dimensional or very complex spaces and effectively kind of find a manifold that is represented by the topology that you defined, and then you can take that manifold and unfold it and look at that space and probably get a better representation. I have trouble viewing outside 1 dimension, 2 and 3 are challenging, 5,000 I don't even try. So this is a simple example using a shape, which is actually supposed to be a rabbit, which was actually a 3-dimensional model of a rabbit. And they used the self-organizing map to see how can we represent that 3-dimensional shape. And you see what it's doing is it's just taking that flat topology and folding it over that 3-dimensional structure in that space. Simple stuff, right? So how do they actually work? So again, this kind of goes back into the general duality of these things. And so what happens, the red dot represents a data point. So I picked a data point in my original data space at random. And what I do is I find a winning node in the map, which one's the closest, that's the green one. And what I then do is I move that green one, the winning node, I move it closer to that red one, the one in the data space, using its data space representation. Then using the topology, I find its topological neighbors, and I also move them closer, but not quite as much as the first one. Then I find their topological neighbors, and I move them closer, but not quite as much. And so you basically are trying to model that high dimensional space, the actual space you're trying to work in, using this topological relationship and letting it kind of adapt slowly. And so there's a decay function that tells you how much each one of these should adapt. And you also have other decay functions. This is how far do I move it? You let this go over time. It's kind of like a simulated kneeling thing. At first, it's very hot and very flexible and jumping around, and then it kind of cools out and settles down. So this was a nice representation that an intern, I don't know if Matt Marco is in the room, but if he is, he was an amazing intern a number of years ago to put this little simple diagram together. So I mentioned the topologic or the topic modeling, topology. I mentioned that before. That was a Wikipedia representation in a self-organizing map space. What happened is you saw certain things cluster together, like science and philosophy grouped together, and sports was kind of strangely close to those as well. And then politics was just out the weeds. It's neither one of those. So then how I've used it in the past is I've used it pretty extensively in chemistry. And the reason I use this in chemistry is that I had to really represent a very high dimensional, very complex, weird space. So where I was taking chemical structures and trying to turn them into numerical similarity measurements of this chemical structure looks like this chemical structure. And then I was operating at a company where we had about 500,000 chemical compounds in our library that we would typically screen for biological activity. But then we had the ability to buy new compounds that were from groups that just synthesize compounds. We could buy millions, literally, I think one library was 6 million in size. And so the question was, well, we've got 6 million things that we can buy. We have 500,000 things that we already have. How similar are they? How much redundancy is there? Or we can buy 10 million from this group and 5 million from this group. So how do you compare millions and millions of chemical compounds and get a representation? So this is a representation from a paper published by Novartis, where in this case they had 9,000, almost 10,000 chemical compounds. And they were doing the same thing where they were comparing. So up in the upper left, the orange dots represent Novartis compounds, and the blue dots represent compounds that they could purchase. And you can see they kind of separate into islands, and there are some kind of intermediates where, okay, we have some representation there, but maybe we're interested in buying that, or maybe we're not. And then they went the extra step, and they said, we're going to check these things for toxicity. What happens about their general toxicity? And that's what the upper right B figure. So the green compounds are compounds that were safe for this Ames test, and the red compounds were compounds that were very, very Ames mutagenic. They cause DNA mutations. And so then what you find is if you compare these two, is the Novartis compounds are generally pretty safe, which you would expect from this mega pharma company. They know how to make compounds. But they found all these things that we can purchase. Yeah, a lot of these are toxic. We need to be worried about them. So they use that as this particular space. And then I like the D figure, which is really then the chemical representatives of what lives in those particular nodes. So now, and in my experience, when I modeled 1 million compounds and then unfolded that and showed chemists what was representative, they looked at it and they realized, oh, because I know how these are related, I can synthesize these, and I can build a synthesis pathway that will let me synthesize these from that same process. And so it basically then put it in a complex, took a complex world and put it into a language that the chemist would understand. And so that's been really useful. And then the bottom right is basically an extension of that Novartis versus external compounds and their toxicities. And so that's all I have. There's my contact information if anybody wants to get in touch with me. And if you're interested, intrigued in self-organizing maps, I could rattle on, ask the 4 people that cheered for me. They know that I yap on and on about this crap all the time. And this online self-organizing map demo put together by Bern Fritzky is really awesome. So if we can maybe fire that up in a browser while I'm answering questions, I think it would be very sexy if not. Thank you.
So do you know of other areas that this would apply, or have you thought of other areas where you can sell?
Yeah, so I've seen this, like the original figure that I looked was topic modeling, where someone took the entire Wikipedia, and I don't know what the representation that they used for that was for content, but they essentially use self-organizing maps to map that space. So I've also seen it used in image recognition. There was really a really fascinating demo that took a large collection from ImageNet, and they basically put all of these pictures into a self-organizing map using autocorrelation on RGB values. And so they put this into the self-organizing map, trained it for days and days and days and days. And then they created an interface where you could draw in like a paint program, a picture that you wanted to see. And so it would say, okay, I'm gonna look at that, and then I'm gonna find the closest node. And it would come up with a collection of pictures that look just as close as possible to what you drew. I've also seen people use it for curve modeling. And so if you're trying to do a functional curve fit and you're adjusting different parameters to try to evaluate that curve fit, you could take all the different curve fits that you could find and rank them in this map and see kind of the representations and get an idea of, okay, when I change these parameters in this really complex function, how does that modify the overall function and how does it progress throughout the map? So that's where the adjacency really became. And those are just the ones I'm thinking of off the top of my head. I've probably seen hundreds of ways that they've been applied.
So, after having thought about it for around about 3 minutes, it seems like this would be very sensitive to visualization. But I can imagine examples where it's very sensitive to visualization. So how do you deal with that in these things? When presumably you have very large features.
Yeah, so I've got a paper out there, look me up on PubMed, that actually I looked at this looked at exactly that sort of thing of how you train them and the topological representations that you choose, which ones are best, which ones seem to adapt well. And you're exactly right. When you started off randomly, and so the net is just a big tangle. And what I found was that you can adjust your training parameters, your learning rate, and kind of the cooling rate over that time. And if it cools too quickly, what will happen is it will come out twisted. So you get what I call the topological torsion in the overall map. So instead of being flat, it'll be twisted and broken. And then it won't represent your space very well. The way to do that is kind of slow down the cooling. And there are a couple of ways that you can look for error functions. You can look at a topological error function and an overall representational error function. And so the topological gives you an idea, is it twisted? And the representational says, is it actually covering the whole space? So if it's twisted and missing a big chunk, you can evaluate that. And so then it really comes to those learning parameters. Some more sophisticated initialization techniques I've seen use like a principal components initial, there's an algorithm where you can just calculate up to a certain number of the components instead of the whole space. So they'll use, say, the first two, then take a 2D map and just flatten that out in that initial 2D space and let it adapt slowly. So there are definitely ways to get there through initialization and training.
I have more questions, but I'll ask later.
One more question. Anybody else?
I have a question. So how does this compare to techniques that might compute like a network embedding, where the edges of the network have kind of all the dimensions of your space on them? Does it include nonlinearities like you might compute network embedding?
You could. That might be a really long answer, but that's a super interesting question of kind of getting to that. So what you can do is you can define your input space any way you want. And so if you kind of use an embedding space to start with, but that's kind of multi-layer of training in one space and then doing the other. One interesting thing about the self-organizing maps is that you can define your similarity metric any way you want, and you can define your representation space any way you want. So you can actually capture some of that information. But now you've made me think, so I'm not going to sleep for like 2 days. So. But that's cool. Thank you.
All right, thank you. And thank all of you for coming again. So let's see, what do we have on the jars today? So if you have not yet, you need to cast your vote for frequentist or Bayesian. Because the reason why we are able to have free beer are our viewers like you, and the donations that you continue to put over there. So keep the little kitty happy and keep on donating. We appreciate it. And let's see, icebreaker time. So this is an icebreaker from Tony, if we were going to continue the traditions, because I know she always makes a joke and usually points at me and does something. But if you are not one of those people who just wants to get up and talk in front of people all the time or go introduce yourself, this is for you. So how does a required meeting or event feel different than one that you chose to sign up for? Here's your topic. Of course, you don't have to use it. You can just, talk to each other if you want to. But enjoy. We've got the room for another quite a little bit until 8 o'clock. So find our speakers, ask more questions, follow Speckle, and enjoy. Thank you, guys. I think that's it. Thank you much.
Thank you guys for hosting.
Of course, yeah, no worries.
That's great. Hey, you're right outside. Left again.